Okay, so tonight we're doing midterm exam review, as will be happening on Thursday morning, tomorrow morning, and Friday. So Thursday at 10 a.m. and Friday at noon, rather than the Saturday 2 p.m. time that has been moved for this week to 10 a.m. So if you do want more review sessions, the Saturday one seemed like it was going to be a little late to do most people any good. So we are, of course, the Wednesday night session. So I have basically some example questions that I'll be going over, starting with the one that was requested, and then trying to go through kind of in order of ones that I know a lot of students struggle with. So before I get into that, though, just to say I am talking right now. Hopefully if somebody isn't hearing me, they're looking at the slide and following these instructions. And then I'm never sure how long to leave that up, but hopefully if somebody doesn't have sound, they're figuring out that they should. And then just sort of information about how to interact. So you can unmute and raise your hand. If you find the reactions, you can raise your hand to let me know that you have a question. You can type in the chat, of course. You can do other reactions as well. So those are kind of your options for participating, asking questions, and that's definitely welcome for you to do that. So, all right, we'll come back to this at the end to have this feedback form, which certainly if your instructor is giving you any kind of reward for attending, maybe a lot, there's different possibilities it could be, but that's the only way that you know that they know that you attended the session or are watching the recording, is if you go and fill out that survey afterwards. So do make sure to do that. It's also just for our reference to have some idea of how many people are attending these, what you're getting out of them, what you'd like to see. So definitely it's helpful for us, and we would like all of you to fill that out. And it shouldn't take too long to do. Okay, so meanwhile, though, I'm going to go to this. So I'm keeping up the formula sheet on the side here, so we can see, some of the questions you might find the formula sheet helpful. For the midterm exam, pretty much just these first 4 rows. If you're trying to use anything starting with the compound interest, anything from below there on the midterm exam, if you're trying to use those, you're definitely very confused. But any of these top 4, and they're pretty much, we have several that relate to section 1.7, and then you have the quadratic formula. The quadratic formula is good, even if you are pretty sure you have it memorized. Sometimes you get on the test and you're like, I think it's this. So if you have any doubts whatsoever, it's on the formula sheet. You can make sure that you have it right. But so I'm going to start here looking at a question that deals with transformations. And asks about the corresponding points on the transformation graph. And I'm not doing this directly within Math Lab, so I won't be demonstrating the graphing tools, but you did have that in the last week's Wednesday session. So you can go back to the recording of that if you do want to see a demonstration of how the graphing tools work in Math Lab. But this question, so we have this function here that is 3 times x minus 1 squared minus 1. So this, I start out when I'm looking at a function, I want to figure out what's the base function. And yes, transformations will be on the midterm. Everything you've done so far, everything from modules 1 through 3, potentially will be on the midterm. Obviously not every single detail is going to be on there because it's 1 2-hour test. but transformations definitely. If you go and look on the syllabus at like your course outline of record that lists all the topics and objectives for the course, if something's listed in those objectives, it's definitely going to show up either on the midterm or the final. So this is a square function. It's a graph of the base function x squared. So that tells me to begin with, it's going to be that sort of U-shaped graph, a parabola. Then I start looking at what's different between just y equals x squared and this function. So we have the 3 out here and the -1 and the other -1. So I have a -1 inside the square and a -1 outside the square. The 3 out front, it's outside of the square. So it's happening, the square is happening and then the 3 is applied after that. So that's going to be a vertical effect. Anything that's outside is vertical. And when you multiply by a number, that's going to be a stretch or compression. So in this case, it's going to be because it's a number bigger than 1. So we're multiplying by something bigger, making it bigger, taller. It's a vertical stretch. So it's going to make that graph taller. And what that ends up looking like then is also skinnier. Now, if you're using the graphing tool that has the transformations, you don't even have to figure out if it's a stretch or compression. All you have to do is know that you put that 3 in where it says vertical stretch or compression. You just put in the number 3. You should not, I think I can safely say you should not ever be putting anything in the horizontal stretch or compression, just in the vertical. So then we have the -1 inside and the -1 outside. When you add or subtract numbers, that's going to shift the graph up, down, left, right. Inside is horizontal, outside is vertical. Outside, it's fairly straightforward. Subtracting is down, adding is up. Inside, it's a little bit opposite of what you would probably guess if you didn't know. So a subtraction is going to be shifting to the right. So it's shifting right 1 unit, and then it's shifting down 1 unit. And if you think order of operation, the first thing that happens, you take the x value, you subtract, or you basically you shift to the right horizontally. Then the next thing would be the vertical stretch, and then the last thing would be the vertical shift. So that'll come up when we get to the corresponding points. All right, so this particular question has a multiple choice of choosing the correct description. So we're looking for the vertical stretch, the horizontal shift to the right, and the shift down. So we have, let's see, right 1 stretched by 3, up 1 is wrong. See, this one has left 1 is wrong. Vertical compressed is wrong. The next one, shifted right 1 is correct. Stretched by 3 is correct. Down 1 is correct. And just to double check, D says left 1, which is incorrect. So just finding, rather than with MATLAB, of course, if it tried to have you like type in the transformations, that would be more complicated. So, so then the graph, so the basic x squared function, we would have the vertex at 0, 0, and then the first point 1 unit to the right would be 1 unit up. We're moving the vertex right 1 and down 1, so it should end up at 0.1, -1. And then the 3 says that that point 1 unit to the right, instead of being 1 unit above, is going to be 3 units above. So we have that vertical stretch. So if you have some idea of what to look for, even as you're using the transformation tool, then you can tell if it looks like it's doing the right thing. So then we have these corresponding points. So if we just look at x squared, the point -2 would have, you square -2, that would be 4. 0 squared is 0, 2 squared is 4. For the corresponding points, what we're going to do is, remember what we said, it's shifting right 1, And then the vertical stretch by 3, it means you multiply, you're taking 3 times the y value. And then we have the shift down 1. So the right one is going to affect the x, and the stretch and the vertical shift are going to affect the y. So the -2, when that gets shifted right 1, becomes -1. The 0 becomes 1, and the 2 becomes 3. And then the stretch, so we have to do both these things. So we had 4, -2, 4. The 4 gets multiplied by 3. And then subtract 1. So we have the point -1, 11. And if I go to my graph, we have that point. So that would be up here. I didn't draw it perfectly, but somewhere over here. And you can see that corresponds. So the standard graph would have been a 0, 0. So that point moved over here to the new vertex. And then the 0.2 units to the left here, that became this point here, and then the 0.2 units to the right. So they each moved, we moved everything to the right by 1 unit, and then we're making it taller and shifting it down 1. So the 0 times 3, or 0 times 3 is 0, minus 1 is -1. And that matches up with that vertex being at 0.1, -1. And then the 4, same thing here, gets multiplied by 3 to get 12, then subtract 1 and get 11. So you're just taking those transformations, applying the horizontal transformations to the x value and the vertical transformations to the y values. Again, with the vertical, make sure you do the stretch first. If there's a stretch or a flip or anything first, and then the shift. All right, the domain, this is an x squared. The domain is always all real numbers. So -infinity to infinity in interval notation with parentheses. That's true of every polynomial. So if it's an x squared, x cubed. So the only ones that we have in this section where the domain isn't all real numbers, as you're doing the transformations, would be if it's a square root, or if it's a rational where it has x on a denominator. The range, though, we have to look at. So because this graph doesn't cover all the possible y values, it starts at -1, and then it does go up forever. So the range of the basic x squared would be 0 to infinity. This is shifted down 1, so it's down to -1 infinity with square brackets, because there isn't an open circle there at the bottom. There isn't an arrow. It's just the actual graph. So that's that question. The main thing I would say, whether or not it's specifically asked, be able to look at the equation and figure out what are the transformations happening, and what is that graph going to look like, as far as the specific points. Yeah, I mean, you want to be able to do that if it's asked also. And if you can figure out what happens to 0, 0, that will at least figure out the shifts. And so you do the same thing to the other x values. So if the 0 moved to 1, then the -2 and the 2 also had to move the same amount in the same direction. You shouldn't have to deal with, again, with horizontal stretches or compressions, and usually not reflections, unless it's a square root, then that might happen. So that brings me to the next question I want to look up. look at, and that is writing the function. So we have here starting with y equals square root of x. Just one thing to say, make sure you pay attention to what the starting function is, because that square root of x, whatever transformations happen to it, it is still going to be square root. It's not going to turn into a square, a cube, or anything like that. So if it says square root of x, your graph is your equation, it's got to have a square root in it. The exam will be similar to the homework and quizzes in the format. It's still in Math Lab. The questions weighted on the way it's been on the quizzes is pretty much exactly how it's going to be, other than you might have some slightly different questions. But that's why you have the review homework, the practice quizzes, the practice tests, all of that. You're practicing the content, but you're also practicing how MATLAB is asking the questions, how it wants you to give the answers. All of that is going to match up. Okay, so when you have something like this where you're given the transformations, you want to make sure and do them in order. So the kind of thing to note is that vertical changes apply to the entire previous step. So I have this square root. The first step is reflect about the x-axis. So that is, here's my x-axis, and I'm reflecting. So that's actually a vertical reflection, even though it's about the horizontal axis. So that's going to change my square root of x to a negative square root of x. Reflection just puts a negative sign. A vertical puts it outside, a horizontal would put it inside. Then I'm going to shift it down 7 units. So I'm going to take that negative square root of x and subtract 7. And then I'm going to shift it left 8 units. So I'm going to replace the x with an x plus 8. So the horizontal change is going to change what's inside of the function. So what if we had these in different order? What if I switched 1 and 2? So what if it was shift down 7 units and then reflect about the x-axis? So just looking at the graph, what's happening here, we start out with the square root, and then that got reflected. So it's now going down and to the right, and then it got moved down. So it's 7 units below, and then it got shifted to the left. So it's something like this. If I first move it down 7 units from the original, so it's something like this, and then I take that result and reflect it about the x-axis, now that starting point has switched to being above instead of below. So what that looks like with the function is first we do the down 7, so we take the square root of x, subtract 7. But when I do the reflection, I have to apply that negative to the whole previous step. So that turns it into a negative square root of x, but then plus 7 instead of minus 7. And then if I do the shift left, it's still going to change it to an x plus 8. So you have to watch if you have, specifically if you have a vertical reflection coming after a vertical shift, the reflection is going to also switch the direction of the shift. Might help you to draw pictures. You could have a similar thing happen with horizontal, but it's less likely. That does get messier, but it doesn't come up as much. So I'm going to say probably don't need to worry about that. But definitely pay attention to if a reflection is coming after a shift versus before. Okay, I'm going to go on and look at some of those just insanely many questioned, many part rational function questions. So basically, what it asks for, just to go through all these pieces. First, you need to factor. That's always going to be a thing that you need to factor. But the way MathLab wants is, if it would simplify, they don't want you to simplify right away, because the domain is going to exclude values that are factors of the bottom, even if they're also factors of the top. So that would be a hole in the graph. The hole has to be excluded from the domain, the same as a vertical asymptote. So you factor, you look at the factors of the denominator to get the values that get thrown out of the domain, then you simplify. If there wasn't any simplifying to do, then it doesn't want you to type in the factor form again. It wants you to choose already in lowest terms. You have the intercepts. Because it says x-intercepts and y-intercepts, you're just typing in the x values and the y values, not ordered pairs. So it doesn't say type ordered pairs. You're not going to type ordered pairs. For the x-axis, then it asks you to think about the behavior. So that's going to be based on whether the factors was squared or not. So if the factor that intercept came from was squared, the graph will touch but not cross. If it's not squared, it'll cross. Then you have the vertical asymptote. So that corresponds to the factors of the denominator, as long as they weren't also factors of the numerator. It does say type an equation. So you have to start with the x equals on that. And then we have the behavior around the vertical asymptote. So that's going to be, if the factor was squared, it's going to go up on both sides or down on both sides of the asymptote. If the factor wasn't squared, it's going to go up on one side and down on the other. So you want to look for the both sides would be squared. The one side and the other side would be the not squared. Then you have the horizontal oblique asymptote, and that you really want to think of as one question and just ask them separately. But you're never going to have more than one horizontal asymptote, so that should never happen. You're never going to have more than one oblique asymptote. And if you have a horizontal, there's no oblique. There's an oblique, there's not a horizontal. There can't be both of those. So it's really, then the way you determine it, you know, it's going to come out either horizontal or oblique or neither. And those also are an equation. So in this case, it'll start with y equals. And then they have the question about, does the graph intersect? So you would set the function equation equal to the horizontal or oblique asymptote equation and see if there are any solutions to that. Then you have the above or the below x-axis. So that's where you're going to separate the x-axis into pieces. So the divisions happen at every factor. If you go all the way back to the original factored form, anything that's a factor of the top or the bottom, those values become divisions to divide the x-axis into pieces. And then if the factor only shows up once, then at that division, it's going to switch from being above to below or vice versa. If the factor is either repeated, so it's squared on the top or squared on the bottom, or if it shows up on both the top and the bottom, then it's going to be the same on both sides of that. And then you choose the graph. So that's sort of the general, but let me go ahead and I'm going to, so I'm going to write some stuff on the side that's going to stay here. So we have the original function x squared over x squared minus x minus 20. Factored form here is then the x squared is still x squared, but on the bottom, this would be 4 and 5 plus 4 and minus 5. So that would go into the first answer. All right, so then the domain is based on the factors of the denominator. So x is not going to be equal to -4 or 5. And then it's already in lowest terms. There wasn't any simplifying to do on that one. So the factors of the bottom are going to correspond to the domain and the vertical asymptotes. The top is going to determine the x-intercepts. If something is on both, it would be a hole. And if it's a hole, then it's not an x-intercept and it's not a vertical asymptote, but it does still affect the domain and it does still affect the above and below x-axis intercepts, because at that point there's a hole, we have to divide because there isn't a point at the graph there. So we can't say it's above or below the x-axis because it doesn't exist. So you have to watch for that. But this one doesn't have a hole. So we have the x-intercepts come from the top. And so that's x squared. What makes x squared equal 0? 0. So we have 0 for the x-intercept. And it was squared. So it's going to touch only at 0. So not putting an ordered pair, just putting the number and then jumping ahead. It will touch but not cross the axis at 0. Now, there's only ever one y-intercept or no y-intercept. If the x-intercept is 0, that means we have the point 0, 0, and that's both the x-intercept and the y-intercept. There could be more than one x-intercept, but there could only be one y-intercept. So once I know that there's a 0, then that's what it is. But you can also think of plugging in 0 for all the x's. So 0 squared on top, whatever happens on the bottom doesn't matter. Well, if it was 0 on the top and the bottom, it would matter, but then it would cancel. So yeah, if it's 0 on top and that's all there is, then it comes out 0. Okay. So that's the x and the y-intercept. Then the vertical asymptotes again correspond to the factors of the domain. So it's x equals -4 and x equals 5. When there's more than one, they want you to give them kind of an order from left to right. So the negative comes first, the -4, and then so 2 vertical asymptotes, including, so it's typing equations. So x equals -4, and then x equals 5. And then the behavior, I look at these factors and neither of those factors were squared. So I'm just going to, for my own reference, describe this as opposite behavior. But in MATLAB, we're looking for, it goes infinity on one side, negative infinity on the other. I don't have any that do both, so I don't want any of the options that have the both sides. So it approaches infinity on one side of the asymptote and negative infinity on the other. I'm using a comma to separate answers. The x equals is already given outside of the answer box. So here I'm just putting in the -4 and the 5. But because the x equals was already there outside the answer box. All right, so then I have the horizontal or oblique asymptotes. So the rule for these is we look at the leading term of the top divided by the leading term of the bottom. There's 4 possibilities for what that simplifies to. It can simplify to a multiple of a power of x bigger than 2, so a multiple of x squared or x cubed or something. It can simplify to just a multiple of x, or just a number, or a multiple of some power of x on the denominator. If the first, so if there's an x squared or higher left on the top, then there's neither. There's no horizontal asymptote, no oblique asymptote. If it's a multiple of x, you're going to stick a y equals in front of that, but it's going to be an oblique asymptote. Oblique means diagonal, so it's a straight line, but it's not a horizontal line, it's a diagonal line. And the formula for a diagonal line is going to have slope-intercept form. So we need potentially to find the intercept, and you have to do long division to find that. If it's just equal to a number, that's the easiest kind. You just stick y equals in front of that number, and that would be a horizontal line, so it's a horizontal asymptote. If you have x's left on the bottom, then you just have to know or learn that that's y equals 0. There is a logic behind it. You're thinking of as you put in really big numbers for X. So if you're taking that fixed number and dividing it by bigger and bigger numbers, it's dividing into smaller and smaller pieces. That's basically going towards 0. But that's when you probably just need to memorize that if there's X on the bottom, it's 0. Really, all of this you need to memorize. None of this is on the formula sheet. But yeah, did you have a question, Andre?
No.
Okay,
No.
I'm gonna go ahead and mute you. All right. So in this case, the leading terms are the x squared on top and the x squared on the bottom. And that simplifies to 1. So it's just a number. So it's the third option there. I stick a y equals in front of the 1. And is that a horizontal line or a diagonal line? It's horizontal. So that's going to go in the horizontal, meaning there is no oblique. Then we need to look at, well, does the graph actually ever cross that line? Ask that. So I'm going to set the equation, the x squared over x squared minus x minus 20 equal to 1. And solve that. So I multiply both sides by the x squared minus x minus 20. So I get x squared equals x squared minus x minus 20. The x squareds cancel out. And I get 0 equals negative x minus 20. If I add x to both sides, I get x equals 20. So that's the x coordinate of the point. So there is an intersection. X coordinate of 20. What's the y coordinate? Well, we started out with saying y equals 1. We're looking at where it crossed the line, y equals 1. So that's the y coordinate. If it was an oblique asymptote, you'd have to plug that x value back into the oblique asymptote equation to find the corresponding y value, or into the original function equation, because they'll both have the same result. Most of the time, probably on the homework, there was no intersection. So if you're just having to guess, that's usually a safe guess, but there is a method, and it's doable to actually calculate whether there is one or not. So that also gives us a point on the graph, which can be helpful. Okay, so then we have the above and below the x-axis. So I'm going to start thinking about what this whole graph looks like. I have my x-axis here, have my y-axis, and I have the point 0, 0, and I know the graph is just going to touch there, so it's going to be the same on both sides of that, but that is one of my divisions where it's not above the axis at that point and it's not below, but I know it's going to be the same on both sides of that because of that square, because it's just touching. Then I have the vertical asymptotes at -4. And I know it's going to be opposite there because that factor was not squared. And then at +5. And again, it's going to be opposite. It's going to switch on either side of that. And that takes care of all 3 factors of the top and the bottom. So I get 4 pieces here. -infinity to -4, -4 to 0, 0 to 5, and 5 to infinity. Those 4 intervals are going to be put in the boxes of either above the x-axis or below the x-axis for that whole interval. How do I figure out which is which? Well, I need some other point, and I have one. I have this 21, so I know somewhere. I also have the y, or the horizontal asymptote. So I know somewhere way over here, the graph crosses that y asymptote, but that means it's above the x-axis there, and so that means it has to be above the x-axis in that whole part. So it's going to have to come up alongside this vertical asymptote and cross over. So probably what it's going to do is going to cross over, and then it's going to come back and flatten out. probably over a very long distance and would barely show up if you actually look at the graph, but that's what's going to happen. But you don't need to worry about that. You just have to know it's above. It can't cross on down because there's not an x-intercept over there. So it has to stay above the x-axis. But it has to go up because it has to stay above the x-axis, and it has to go towards either positive or negative infinity at the asymptote. It has to go to positive infinity because it's above on that whole part. Then it has to switch. So it's going to be below, pointing down on the other side of the asymptote. It's going to come and touch the x-axis. Then it's going to go down again because it's this just touching, not crossing. And then we have this piece over here. And so we can fill in then the above and below the x-axis. So it's going to be above on the intervals. Let me just write these down. So we have above here, and then we had below, and above. So the above are the negative infinity to -4, and the 5 to infinity. And it does say use a comma to separate. So even though it's interval notation, you're going to use a comma rather than the union symbol that you would usually use with intervals. Then the below intervals are -4 to 0 and 0 to 5. And then I can pick the graph, and I've sketched what the graph should look like, and I can tell like D and C here only have one vertical asymptote, so they're no good. And then looking between A and B, B has the graph crossing at the x-axis, at the x-intercept, and it needed to just touch. So that narrows it down to A. That's the only graph that looks close to what I've sketched here. There are other pieces. Pretty much you should be able to check the asymptotes and the intercepts and the behavior at those, and that should be enough to figure out which graph is correct. All right, so I'm going to do one more of these because there's various pieces that can happen, and so each one is different and different enough, I think, that it's worth doing another one, as long as nobody is asking for some other topic. So I'll try and go a little faster on this one. So we have the factoring here. The bottom is x minus 7. The top, let's see, 28 is 1 times 28, 2 times 14, 3 doesn't work, 4 times 7. We'll give the 3 if it's a positive 7 and a negative 4. Yep. So almost cancels out, but that is, I'm double checking here, but it should be a +7, not a -7. So it's not going to cancel. All right, so that's the factored form. Now, just to say, so if it was x minus 7, let's say it was a -3x instead of a +3x, then you would end up with basically the graph of x plus 4, but you would have a hole at x equals 7. So that would affect the domain, and it would affect the above and below the x-axis. You'd have a division there as 7, even though those factors have otherwise disappeared. But we don't have to worry about that here. The domain is going to exclude just the 7, and that's also going to be the vertical asymptote is going to be x equals 7, just one of them. And it's not squared, so it's going to be infinity on one side and negative infinity on the other. No opposite behavior there. I just note for when I'm going to draw the graph. And then going back, they ask for the simplified form. Since it was already simplified, I'm not going to type it in again. I'm just going to say already in lowest terms. Then we have the y-intercept and x-intercepts. The x-intercepts correspond to the top. So that's going to be to the numerator, the -7 and the 4. For the y-intercept, I'm plugging in 0 for x. So that's going to be 0 plus 7 times 0 minus 4 over 0 minus 7. Or it might be easier even to plug into the original function. So because as long as there's a constant on the top and the bottom, like that's what you're going to end up with. So the -28 over the -7. So that comes out 4. The x-intercepts there at -7 and 4 are both they're both cross. Nothing was squared, none of the factors were squared here. So the graph is going to cross at those points. So that brings us to this next part. Will cross the x-axis at each of those values. When you're just listing those numbers, they can be in either order. So then we have the horizontal or oblique asymptote. So in this case, the leading terms, we have x squared over x simplifies to x, and that's the type that's going to have an oblique asymptote. So I'm going to have y equals x. That's not a horizontal line, it's a diagonal line, so there's no horizontal asymptote. But I'm not done yet. I now have to do a bit of long division to figure out, or with this one, with the x minus 7, you could use synthetic division if you're comfortable with that. But I don't have to do the whole long division process, just a couple of steps of it. So I set up the division. The first step really is already done. The x squared divided by x, that gave the x that we have to start with. I need to multiply that times the x minus 7. And then I need to subtract that whole thing. So that's really going to become a minus x squared plus 7x. And so that gives me a 10x minus 28. And the last thing I have to do is just take that 10x divided by the x of what it's being divided by, and that comes out 10. I don't need to figure out remainder or anything like that. So we have x plus 10 there. And then for the intersection, I'm going to set the function, so the x squared plus 3x minus 28 over x minus 7 equals x plus 10. So I'm going to multiply by the x minus 7, and that comes out, shortcutting a little bit, x squared. There's going to be a 10x minus 7x, so plus 3x, and then minus 70. But now I have the x squared plus 3x on both sides, so those cancel each other out, and I get negative 28 equals negative 70, which is false. So that means there is no point of intersection. And that brings us to the above and below the x-axis. So I'm dividing the x-axis at the x-intercepts, which were -7 and 4. And at the vertical asymptote, which it was +7. So those are my divisions, -7 4, and positive 7. So I have the 4 intervals, negative infinity to negative 7, negative 7 to 4, 4 to 7, 7 to infinity. These intervals are always going to be parentheses, no square brackets on those. So then I just need to figure out, it's going to be opposite. It's going to change at each of these because none of the factors were squared. So it's going to alternate above, below, or below, above, below, above. So all I need is 1 point in one of those intervals, and I've got it. I've got the y-intercept is 4. So that tells me that this middle piece here is above. And then I can fill the rest. We have then below, and then between 4 and 7 below, and on the other side of 7 above again. So the graph is going to, we can kind of connect these points somewhere or other. Don't know for sure what it's going to do in between, but it has to come to those x-intercepts. It's going to go down here. It's going to then be up on the other side. But we do also have that oblique asymptote. So that was x plus 10. So 4, 5, 6, 7, 8, 9, 10. So we have this diagonal line here. So we're actually going to have a piece of the graph way up here in the corner, and then the other piece down below crossing the x and y axes. But so to fill in then, the above intervals were negative 7 to 4 and 7 to infinity. And the below was negative infinity to negative 7 and 4 to 7. These intervals, notice it covers the entire x-axis, but I definitely recommend you don't try and figure out what are the above ones and what are the below ones separately. Just look at all of the pieces as a whole. So then choosing the correct graph, I'm looking for an oblique asymptote, which these all have. The oblique asymptote needs to have a positive slope. There was positive x, so that eliminates these two. And then it needs to have a positive, it was x plus 10, so it's crossing the x-axis at a positive point. So that eliminates this one. You can also tell here the intercepts are wrong. It looks like the x-intercepts are all to the right. And then looking at this one, it seems like there are the two x-intercepts that should be in the correct arrangement with the intercepts, the asymptotes. And so that would be the correct graph. So lots of pieces on those. Very challenging to get all of the pieces right. If you can come up with the correct intercepts and asymptotes, like those are the most important pieces. The behaviors are semi-important. After midterms, there'll be a whole section that talks about, or actually 2 sections, kind of looking at the whole above and below the x-axis question. So to me, that's a bit much to have here, but it's, if you know how to do it, it's not that, but there's just a lot of little notation things that can go wrong, and depending on your instructor, they may give more or less partial credit if you just left out a parentheses or something. But yeah, so that's rational functions of that type. Next up, I'm going to go and look at a question that's identifying characteristics of the graph of a function. So you're given a graph. In fact, you're asked first to figure out, is it a function or not? These ones you have to watch out, because if it's not a function, then it doesn't want you to actually answer the rest of the questions. But if you mistakenly say it's not a function and then don't answer the rest of the questions, you've immediately lost all of the possible points there, versus, if you answer those questions, So I guess just make sure that you really, really know how to tell if it's a function or not, so that you aren't losing all the points. So is it a function or not? Vertical line test. Is there anywhere where a vertical line would cross that graph more than once? If you've ever watched like copy machine or scanner work, and you have that like light that sort of moves across. So think of the vertical line like that light moving across, and is it ever having more than one point on the graph touching it? And in this case, that doesn't happen. It is a function. So then we have the domain, range, intercepts, and then the symmetry. The symmetry is a bit tricky because we actually didn't do the section that defines symmetry. We did talk about that in, I think it was in the week, the module 2 live lectures a little bit. But so I'll talk about that. But domain, when you're looking at the graph, you want to think X values from left to right. And in this case, we have arrows pointing in both directions. So that's going to make the domain be all the way, everything is included. So negative infinity to infinity on this one. For the range, you want to think of the Y values from bottom to top. So we do have a top here at 8. It doesn't go above that, but we have those arrows going down. So we're going from negative infinity, stopping at 8 with a square bracket, because there weren't at the top, there were not arrows, there were not open circles. So there are actual points that have a Y value of 8. All right, for the intercepts, I'm looking at anywhere that the graph touches or crosses either axis. So I've got one here, one here, one here, and this, it does say type an ordered pair. That's the only way in this case of knowing whether it's an X or Y value. So I have to be careful reading this graph then as well. So I have negative 20 here, and there are 5 spaces, so each space is 4. So that makes this negative 12 and this positive 12. And then here, it's also counting by 4 because 4 spaces gets to 16. So this is 8. So you want to be careful. You should be able to like zoom in on the graph a little bit if you need to read that better. But so this is going to be then X value first, then the Y value. So the negative 12, 0. And the Y-intercept of 8 is the 0.08. And the X-intercept of 12 is the 0.12, 0. Those 3 points could be listed in any order as long as you have the right order within the points and you have the parentheses and the commas and everything. All right, then the symmetry. Symmetry with respect to the origin is rotational. So you have the origin, you have whatever the graph is doing over here. It has to have a corresponding piece 180 degrees rotated around the y-axis. This corresponds to odd functions. So something like the cube function. So it'll often take on kind of an S shape. If you think of like something spinning, where you start to see those sort of curves that are around the center, that's what you have going on with symmetry with respect to the origin. And we certainly don't have that on this graph. Symmetry with respect to the x-axis is the x-axis would be the mirror. It would be a reflection. And that is never going to happen with a function, because that would mean I have to have the piece above the x-axis, the matching piece below the x-axis, and those immediately fail the vertical line test. Y-axis, though, so now the y-axis would be the mirror. That is going to correspond, so you have a piece, all right, matching piece on the left. That's going to correspond to an even function. It does have to perfectly match up. So we have here the 8, the positive 8 with the 8, and the negative 8 with an 8. We have the positive 12 and the negative 12. But if this was like negative 8, 8, and then 9, 8, so it's like shifted over a little bit, it wouldn't have that symmetry relative to the y-axis. It has to perfectly match up. But this one does, so this has symmetry with respect to the y-axis, making it an even function. So see if I can squeeze one more in here. Looking again at a function question, thinking about points on the graph of a function. But this is one where you're given the equation and asked questions about it. So in this example, we have f of x equals 3x squared minus x minus 2, and asks different questions. So first, is the point 2,8 on the graph of f? And we have a couple of things going on. The point is an x value and a y value, but I also have y and f of x are interchangeable. So this can also be thought of as asking, is f of 2, so 2 is the x value, equal to the y value of 8? So the x inside and the y is what it's equal to. And the way to figure out if f of 2 is equal to 8 is to calculate f of 2. So f of 2, f of anything is, so another way to think of this function rule, whatever is inside this parentheses, wherever there's an x, that same thing goes there. So f of something is 3 times that thing squared minus the thing minus 2. What we're plugging in this case is 8. So 8 squared is 64. Minus 8 minus 2. 3 times 64 is 192 minus 10. Certainly not equal to 8. Oh, I did f of 8, not f of 2. That's no good. We're looking for f of 2 and figuring out, is it equal to 8? I keep doing the wrong writing tool. All right. All right, now we have 3 times 4 minus 2 minus another 2. 3 times 4 is 12 minus 4, and that actually does turn out to be 8. Now it could have been, it didn't have to turn out to be 8. This could be a yes or a no. But so in this case, yes. So that narrows me down to options A or B here. And substituting x into 8 certainly didn't result in 2, and that wasn't the right thing to do, but substituting 2 in did result in 8. So there's that. Then we have, if x equals -1, what is f of x? So in other words, what is f of -1? And then the point on the graph is going to be a point with a -1 for the x, and then whatever value for the y value. So f of -1 is 3 times -1 squared minus -1 minus 2. So that's 3 times 1 plus 1 minus 2, which is 3 minus 1. So that's 2. So f of x equals 2, and the point is -1, 2. Then they ask, if f of x equals -2, what is x? So now we're trying to find x. We're not plugging something in for x. We're trying to find x. So f of x here, we're told, is the 3x squared minus x minus 2. So I'm taking the 3x squared minus x minus 2, setting that equal to -2. The point, then, we're looking for the x. The -2 is the y. So add 2 to both sides. 3x squared plus x equals 0. Factor out the x. X times 3x plus 1 equals 0. That gives me 2 equations, x equals 0, or 3x plus 1 equals 0. and solving that, we get x equals -1/3. So we have those two possible x values, 0 and -1/3. And that gives the two ordered pairs, 0, -2, and -1/3, -2. Right. The domain of any polynomial is all real numbers. So you only have to do work to find the domain if you're looking at a graph, potentially, if there's a square root with an x in it, or if there's a fraction that has an x on the bottom. The x-intercepts, you set the whole thing equal to 0. I'm not going to take time to do that, but you would have to solve that. For the y-intercepts, you just plug in 0 for x, and it's going to come out the -2. But notice we're not putting ordered pairs because it didn't ask for ordered pairs. But that's a slightly abbreviated, that question. So if you have further questions as you're studying, or if you want to see, there may be some of the same questions and some different questions covered in tomorrow morning session and in Friday's session. So definitely put those on your calendar, at least to be aware of, and attend if you want more of this. But let me just go ahead, and I apologize for going a little long, but let me throw the link into the chat here. And you can also just copy it from the screen, but do please go and fill out the survey. You can also find this link if you go like on your course home page. Your instructors have been asked to add this to your course home page to have this link to the lecture schedule. That's also going to have, that's going to be where the recording links are. Has links to the feedback forms, has the content that should be covered. So make sure that you're aware of, know how to get to that form. The only glitch in there is you do have to make sure you're signed into your Ivy Tech Gmail account, or it won't let you in. Yeah, so any other questions before I close this meeting?
I got one.
Okay.
When is this gonna be posted?
When's the recording going to be posted?
Yes.
It should be by tomorrow. By tomorrow morning, hopefully.
So I got another one.
Okay.
So all the formulas that's in that sheet is getting covered on that test.
No, so that formula sheet is for both the midterm and the final. So I show you like the first
What?
4. So everything past the first 4 are stuff that's going to be on the final exam. So if we look at this, if you're looking at this, like everything starting here is not going to be familiar to you yet. We haven't done that yet. So as you're taking the midterm, you shouldn't be looking at any of those. You should just be referring to possibly these first 4 formulas. Then when you get to the final exam, that bottom 2/3 of it is going to hopefully make sense and be useful for you.
So it's gonna be some hidden formulas then.
Yeah, so there's not a lot. So all of the like transformation rules, the all the stuff about the rational equations and the polynomials, all of that, like that's not on there. The only thing on there, like I said, is those formulas that you might use for section 1.7, those word problems, and then that quadratic formula. Anything else? So you also have a study guide. So this is also linked here that kind of goes through like, here's all the stuff that you need to know how to do, need to know for the midterm exam. So you might find that helpful. You have, of course, the review homework,
But isn't in that
the review quiz, the practice
that
quiz.
Excel?
This is a Google Docs
Google
file.
Docs.
But it should be, your instructor at least was asked to put it just like on your course homepage, just like this. So you can just click on it there. But the study guide, you might have also had an announcement posted or an email sent to you with a link to that. And it is, it's a lot of things. But hopefully as you look through it, most of them you can be like, okay, yeah, I know how to do that. I know how to do that. Oh, this one, maybe I need to practice extra. And it gives you something to sort of more generally than just doing, but you definitely want to be doing the review homework problems, the review quiz, the practice test. All of those will give you the practice of the content, but this will give you sort of more the notes or what you need to study or memorize or know how to do.
Yeah, thank you. I was just asking. I'm like, I was looking at him like, was all of this gonna be covered?
Yeah, no. So that's why I said like, because sometimes students look at the formula sheet and I'll sometimes see students on the midterm exam, like trying to make one of the, those other formulas work. And I'm like, you haven't even done that yet. All right.
Okay, that's all I needed.
All right. I'm going to go ahead. I'm going to stop the recording and stay on for just a minute in case anybody has questions they want to ask that they don't want to be on the recording.